Okay, so we restarted the video. Just had a little cough. So 45 cents times 100, going back to letter C on page 562. If you think about what 45 cents means, that is the same as putting a decimal point here and a dollar sign here. So you can switch this, if you wanted to looking more like $0.45. And then thinking how many decimal points would there be? It's still money. And so we have 45 cents times 100 is $45. Okay, and so what if it was just one more zero? Actually, I noticed that the original problem in C, and I'm sure you noticed this too, actually was 45 cents times 1,000. I had said it was 100. So what will be the difference if we do this correctly? It will have 3 zeros up here and 3 zeros down here. So 45 cents times 1,000 is not going to be $45. But there will be 2 decimal points, as there always are with dollars and cents. And what do we have is $450. So good catch for those who noticed that to begin with. Okay, what about example number 2? I'm going to read it while I erase. So pay attention to example 2 on page 563. I do want you to be looking in your book and following along. So in example 2, it says a cement company delivered 10 tons of cement to a construction site. It's quite a bit of cement. How many pounds is that? Okay, well, we've already learned in a previous lesson that 2,000 pounds equals 1 ton. So we need this knowledge, first of all. 2,000 pounds equals 1 ton. And so we can multiply 2,000 times the 10 tons of cement that we were told in the first place. And we would say, well, 2,000 times that multiple of 10 is very simply that 2,000. 1 times 0 is 0, 1 times 0 is 0, 1 times 0 is 0, 1 times 2 is 2, and add 1 more 0, which is the 0 that we're bringing down. I could have written that a little clearer. Let me try again. So 0, 1 times 0 is 0, 0, 1 times 0 is 0, 2, and then if you were to bring that 0 down, sometimes we put a line if we want to, just to differentiate where that 0 is hanging off, and then we just bring that down. So, but in the end, we don't need that line here. We want to see the number all at once, and we think, well, is this dollars and cents? No. Is there a decimal? No. So all we're going to do is start at the right and count from the right to the left digits to find out where we put our comma. So 1, 2, 3, comma. And the answer is 20,000. 20,000 what? What's your label? Label really matters. The original question was, how many pounds is that? And the answer is 20,000 pounds of cement. How many pounds of cement? 20,000 pounds of cement. Okay, so that brings us to our lesson practice problem. Go ahead and write down letter A and get started on that, and I'll catch up to you in just a second. Okay, so multiply mentally. That doesn't mean you don't write down what your answer is. It means you think about this in your head first. 365 times 10. Oh, there you go. Notice that I'm drawing the line just up to the 1 and not to the 0 so that I can differentiate. You can do it the other way. You absolutely can. In fact, I think your book does. Yes, it does. You can draw the line if you wish to do that. And we get started. 1 times 5 is 5. 1 times 6 is 6. 1 times 3, of course, is 3. Bring down the 0. And our answer is 3,650. Now, if you did it exactly as the book asked, which was mentally, then you should have just taken 365. It's times 10, so we add 1 0, and there's our answer. Okay. And what about for letter B? Can you do letter B, please? And go ahead and write down your answer. And again, I'll catch up to you in just a moment. Okay. All right, so letter B. 52 times 100. Well, there's 2 zeros in 100, so our answer is 5,200. Let's try letter C. 7 times 1,000. Okay, so write down the 7, and there's 3 zeros in 1,000, so 7 times 1,000 is 7,000. Let's think about letter D. Letter D is $3.60 times 10. So write down the numbers for $3.60, and notice that when we add a 0 to $3.60, let's say here's $3.60, if we add 1 0, what we're also doing is moving a decimal point over by 1 space. So the answer now becomes $36. Okay. Add 1 0, move the decimal point over to the right by 1 space. If you add 2 zeros, move the decimal point over to the right 2 spaces. If you add 3 zeros, same thing, but move the decimal point over 3 times. Okay, so that leads us to letter E. Letter E says 420 times 100. So let's write down the 420. We're multiplying by 100. And since we're multiplying by 100, 100 has 2 zeros. We're going to add 2 zeros. And then there is no decimal point, so we're not going to put the decimal point with 2 spaces over. What we'll do is we just need a comma here. So 1, 2, 3, comma, and there's our answer for letter E, 42,000. Okay, let's move on to letter F. And here we have $2.50. So I'm going to go ahead and write down that amount of money just like it is for us to look at it. And then it says times 1,000. Think about that 1,000. I'm going to go ahead and write it on the board for us to look at. Excuse me. So $2.50 times 1,000. So what do we have here? We're going to write all the numbers down, 2, 5, 0, just like before. And we're going to add 3. 1, 2, 3 zeros. 1, 2, 3 zeros. All right. Once we've done that, we have to think, is this dollars and cents, or is this just a whole number and we need to count to find where the comma goes? No, this is clearly dollars and cents we're talking about. So what we're going to do is put the decimal right here, because there's 2 digits after a decimal in money. So we're going to do that the same way. This time it's a little different, just in that we have our decimal point and then we can count 1, 2, 3 to write 2,500 very clearly in money form. We don't have to have the comma. We can completely leave it out if we wish, or we can have it there. It's up to us. Usually with money, we would leave that out until the amount gets bigger than the thousands. Okay, let's see. Then we have letter G. We are actually going to skip letter G for lack of time, and so go ahead and skip down to our written practice, and we're going to try to do the most important problems to help you. And keep in mind, as I always say, you can stop and take a you can pause if you need to, so that you can look at something again, rewind a little bit. Whatever it is you need to do is fine. So, but if you're wanting to take a break, make sure you ask your parents, please. Okay. All right. I have a pretty clean board now. Let's get started. All right. So we're going to go get started on our practice problems. The very first one is number 4 in lesson 84. And this problem says Shunsuke, another interesting name, Shunsuke, bought a pair of shoes priced at $47.99. The sales tax was $2.88. Shunsuke gave the clerk $60. How much change should he receive? All right, so it looks like we have to add the amount plus the sales tax, and then we have to do a little bit of subtracting from the $60 to see what the answer will be and how much change he should receive. Now, does this call for an estimation? It does not. It did not say about how much change should he receive, causing us to estimate it. We need an actual exact amount of change, which is what you would want when you're spending your own money, right? So number 4, we have that original $47.99, right? Then we have $2.88 to add to it, and whatever amount we get here, we are going to subtract it from that $60 that he gives the clerk. So I'll just put that down so we don't forget about it. All right, so 9 plus 8 is 17. 9 plus 8 plus 1 is 18. Okay, we know 7 plus 3 really is 10. I'm going to put the 0, but not forget my decimal point, and not forget to carry that 10 over. And 4 plus 1 is 5, so I have $50.87. That is really close to $60. So now I'm going to put that amount here, $50.87, which brings us to a different lesson that we've had before. If you take a look at number 4, you'll find out that lesson 28, 51, and 52 all had to do with this problem. Okay, so subtracting from zeros. Well, can't do 0 minus 7, can't do, we cannot borrow from the 0 here or the 0 here. We have to start at the 6. So now we took from that $60, which is what it was if you think about it, and we are going to leave $50 and some single dollars and some cents. So what are we going to do? We're going to cross out the 0, and we are going to give $9 here. So add a 9. We're going to cross this out, and we're going to give 90 cents here, and the final one goes here. So this is, so we now continue on with the subtraction. 10 minus 7 is 3, 9 minus 8 is 1, 9 minus 0 is 9, 5 minus 5 is nothing. So we go ahead and put our dollar sign, and our final answer is $9.13. Okay, and go ahead and get that down on your paper, and then I will move on to number 6. Number 6 says, the mass of a dollar bill is about 1 gram. So use this information to estimate the number of dollar bills it would take to equal 1 kilogram. So we remember that, let me just draw, let's see if I could draw a $1 bill. Okay, if a $1 bill has the mass of 1 gram, then if I now have a kilogram, which remember is the same as 1,000, kilo means 1,000, so it means 1,000 grams, then it's this dollar bill times 1,000. So use the information to estimate the number of dollar bills it would take to equal 1 kilogram. Well, that would be that dollar times 1,000. So it would be 1,000 dollar bills. 1,000 dollar bills. I bet that would be fun if you had that in your hand now to count and then spend, right? Once we're out of quarantine, that would be fun. Okay, so if you are finished writing down number 6 and you understand it, then move on to number 8, and we will get started on that in just a moment. Okay, number 8. Tamara knew that her trip would take about 7 hours. If she left at 9:30 in the morning, so think 9:30, that's 9:30, right? Around what time should she arrive? All right, we can do that. So she left at 9:30 in the morning. So she left at 9:30 a.m. Okay, now think 7 hours past this. Okay, so it's a.m., 9:30. I'll just count on my fingers. 7 hours. 10:30, 11:30, 12:30, 1:30, 2:30, 3:30, 4:30. So 7 hours later is 4:30 p.m. Right? When you do a problem like that, it's best to do it a couple of times to make sure you got it right. But I can assure you that that is correct. So that was letter A. Letter A, the answer was 4:30 p.m. Now, if Tamara traveled 350 miles in 7 hours, then she traveled an average of how many miles each hour? Notice that word each gives us a clue in any story problem that we want that as the first line of our story problem. So for 8, now B, we say she traveled 350 miles in 7 hours. Okay, so then the question is, how many miles did she travel each hour or per hour, right? That becomes our question, or that is our question. Times, which word do we typically drop down for the next line? We drop down whatever shows up at the end, per hour or each hour or in an hour. And then, as I taught you, bring down this second word, which in this case is miles. Okay, so then ask yourself, do you know the number of hours, or do you know the number of miles, or do you know both? In this case, we know both. So 8B said that it was 7 hours, and it said that the total she went was 350 miles, right? So that means some number times 7 equals 350, okay? And obviously we need to do the opposite of multiplication because we know the final part of this, the third line, and one other. So we say 350 divided by 7. And actually I'm going to write it here where I have a little bit more room to work with. Checking to see that you can see that. It's on the video. 350 times 7. Cross this out really quick. Okay, so we think 7 times what goes into 35. We know the answer to that is 5. 5 times 7 gives us exactly 35. We subtract. We bring down the 0. And we ask ourselves, okay, what times 7 gives us 0? Or 0 divided by 7 equals what? And we know that only 0 times 7 will give us zeros. So there you go. And of course, if you added another 0, you'd just keep continuing on with zeros. We don't need to be doing that in any way. So 350 divided by 7 is 50. So we know that the third piece of this is 50. And doesn't it make sense to you? 50 times 7 is 350, or 5 times 7 is 35. Add a 0 is 350. So I'm sure some of you could do that in your head, but if I do it on the board, I want you to absolutely have all these parts and pieces written down on your paper, and I will be looking for that. So now, part C, use your answer to part B and make a table to show how far Tamara would travel at her average rate in 1, 2, 3, and 4 hours. All right, so I'm going to remove just part of this so that I have a little bit of room for the table, which is part C. Okay, part C. And we're going to think about, okay, so now that we know miles per hour, that 1 mile takes this person 50 miles. We're going to make a table, and we're going to call it, maybe at the top, we're going to have hours and miles. Okay, so in 1 hour, we know that Tamara goes 50 miles. We also can then gather in 2 hours, she'll go 100, right? 3 hours, add 50 more, she will go 150. And in 4 hours, she will go 200 miles. Does that answer our question for C? It does. I believe you will find that it does. So we can move on to number 9. Now, if you need a moment, take that moment, pause it, and go ahead and get all of this information down. So number 9 now says, the product of 7 and 8 is how much greater than the sum of 7 and 8? So I need just a moment to get my board ready. Could you write down the problem as you think you would need it to be showing? Again, so the product of 7 and 8, so you're going to multiply 7 and 8, and then it says how much greater, so that's a comparison now, so you'll need a subtraction sign there, and then from there you're going to do the subtraction and get your answer. Okay. So the product of 7 and 8, we can start it off just like this. 7 times 8. I'm grouping that together because it wanted the product of these two numbers. And then it said is how much greater than the sum of 7 and 8. So because it asks for greater, how much greater is this, I'm going to put that subtraction sign, like I said. And then the sum of 7 and 8 we would get by adding together these two numbers. So I'm putting that in a separate parentheses. And now I'm going to go ahead and do this problem. Okay, I'm going to put an equal sign at the end because once we do all of this, we will have the answer. Okay, let's see, 1 second, let me adjust this board a little bit. So 7 times 8, we'll do the first parentheses, that gets to go first. We know 7 times 8 is 56. Okay, then the other parentheses, well, we know 7 plus 8 is 15. I'll leave the parentheses out, I don't need that anymore. I will bring down the subtraction sign and the equal sign. So now I have this problem that is 56 minus 15. You might be able to do that in your head. 6 minus 5 is 1, and 5 minus 1 is 4. But for those of you that have an easier time writing it on the side, please do that. 6 minus 5, 1. 5 minus 1, 4. And we see that the answer is 41. You could have written it here if you were sure. But either way, whether you do the final simplification on the answer or just write it off to the side this way instead of finishing the funnel, the answer is 41, as you can see. Okay, so that's number 9. Let's move on to number 11. Number 11 says, Shakura purchased a birthday present for each of 2 friends. Including sales tax, the cost of one present was $16.61, and the cost of the other present was $14.37. What is a reasonable estimate of the total cost of the presents? It's an estimate. It is rounding that we need to do. We don't need to know exactly the amount, but $16.61, I believe you would agree with me that you would round that to $17, or number 11. And then the other amount, $14.37, well, we could round that down to $14. And what's a good estimate? Well, 7 plus 4 is 11. 1 plus 1 plus 1 is 3. And we can say, well, if we round it to the nearest dollars, we have $31 as an estimate. All right, number 12. I think I'll do that one right over here. Save some time. It says, what is the product of the 5th multiple of 2 and the 8th multiple of 6? Remember, the 5th multiple of 2 is the same as 2 times 5. So 2 times 5 is 10. And the 8th multiple of 6 is 8 times 6. So it is 10 times 48. I'm going to write it this way to make it easy to multiply by that multiple of 10, which is what this lesson is about. And we have 1 times 8 is 8, 1 times 4 is 4. You could have just simply said, oh, that's 48 times 1, that's 48. Add the 0, and we get 480. Okay, number 13. Number 13, I think I'll erase for this one. Go ahead and get started on 13. Always try to get started before me if you can, so that you are already thinking about that problem before I even get there. If you're fast enough to do that, that's awesome. If not, that's fine, no problem. Follow along. So number 13 says, draw and shade 2 circles to show that 3/4 equals 6/8. So 3/4 equals 6/8. All right, well, I see a 4 and I see an 8. The 4 is, that's pretty simple. Just divide into 4. 1, 2, 3 of them. Is that equal to 6 out of 8? Well, since 8 is just a double of the 4, I can divide it into 4 and divide it again. So now I have 8 pieces, and I want to shade the same areas. So 1, 2, 3, 4, 5, and 6. If you take a look, 3/4 is exactly the same as 6/8. Okay, and let's see, number 14. It says, which of these words does not describe triangles ABC and DEF? ABC and DEF. Well, take a look at those two triangles. I see 2 similar triangles. They look like one is a mirror image of the other. So therefore, is A true? Yes, A is true. Those two are similar. How about obtuse? Are these obtuse triangles? Meaning that there is at least one obtuse angle in it? Yes, it is. Angle C is obtuse. It's bigger than 90 degrees. And angle F is obtuse, bigger than 90 degrees. What about scaling for C? Scaling asks you to verify if that a triangle is all different lengths. And if I take a look, sure enough, all the lengths of one of the triangles are different lengths. Okay, so then none of those work. Those are all true. We're looking for something that does not describe these triangles. And what we find is D is the right one, because isosceles, these are not isosceles triangles. An isosceles triangle, if you recall, means that 2 sides are exactly the same length, and that's not true here. All right, so let's move on to number, let's go to, how about number 25? Number 25, 60 times 100. 60 times 100. Hopefully you're getting the hang of this. 60 times 100 is 60 with 2 zeros, and the answer is 6,000. Okay, now let's take a look at number 26. 26 has 3 different triangles, and it says below we show an equilateral triangle. And I'm not going to draw this. I think you're old enough and mature enough to look at these 3 triangles and look with me at the book and also listen and watch me. So we have first an equilateral triangle. All 3 sides are the same and equal lengths. Then we have an isosceles triangle next, where the 2 top sides of the triangle, the 2 that go vertically, are exactly the same length. And then we have a scaling triangle where none of the sides are the same length. Now it says, name the triangle that does not have reflective symmetry. Well, if you cut the first triangle, an equilateral triangle, you'll have symmetry. If you cut this right down the center, maybe I will draw it for a second, you'll see that the 2 sides are equal. If you cut one that is an isosceles where 2 of them are the same, you could cut it right down the middle and you will see reflective symmetry. But instead, if you take a scaling triangle, such as this one drawn here, where none of the sides are equal, this side would be, it shows in our book a little better than mine, but this side is longer than the others, then you will find that there's no way to break this up and have reflective symmetry where they're the same on the same side. So the triangle that does not have reflective symmetry is the scaling triangle. Okay? All right. And for that, all I really need you to have down is this piece here, scaling triangle. All right, so that brings us, we have numbers 28, 29, and 30 to do, and we are going to skip lesson 28 I'm sorry, number 28. It's a really good one to look at, but it's really hard to show this one to you. But I will quickly just tell you that if you do look at that, and I would love for you to look at that, the measurement there of segment AB is 1.8. So for those of you that want to try that, it is 1.8 centimeters. And I would love for you to do that, but I won't take the time to draw out a ruler and all that. It would take too long. Number 29 says, name a pair of parallel edges in the figure at the right. Okay, so this particular one, if you could read it and think about it while I get my board ready, clean this up. All right, so this particular one, number 29, shows us a cube. And I hope you can see that okay. Can you see that okay? Let's see, let me get that a little clearer. All right, so here is the same cube, almost perfectly drawn, the best I could anyway. And it says, so name a pair of parallel edges in the figure at the right. Okay, so remember the parallel edges we know are two lines that never intersect. They're heading the same direction. So a parallel edge, you could say, would be segment AB. So maybe you would want to say segment AB. Oh, did that wrong. What was I thinking? Hold on. We draw segment this way. Segment AB, we could say, is parallel to segment CD. AB and CD are parallel, or we could say segment AC is parallel to segment BD. We could say segment AC is parallel to segment FH, or you could start with the numbers from the bottom. So there's all kinds of segments that are parallel. We'll just name those two. Now it says name a pair of perpendicular edges. Perpendicular, we know, they have to meet or intersect at a 90-degree angle. So for, this was letter A on number 29, and for letter B, what are some perpendicular edges, right? We draw perpendicular edges like this. And how about we choose segment AC, this one, with segment CD. These two are perpendicular. Okay, so easy as that. All right, while I clean this off, remember to pause it if you need to write that down. But make sure you understand it before you go on. Okay. It's more important that you understand it than it is that you get this information down on paper, although that's important too, obviously. Okay, then number 30 says, what is the length of segment RT? And explain your reasoning. So here, I prepared this in advance, so I don't have to take like 5 minutes to draw it for you. So we have something like this. We have our coordinate graph, and we have the T right here at segment 2, 2. Okay, and then you can spot the R at segment 2, I can't think of the word. At point R, which is 2, 9. So 2 over to the right, 9 up. There we go. This is a coordinating pair. And then we see a line. It's not red like mine is here, but we see a line right there. And it says, what's the length of segment RT? Let me go ahead and make sure I name it. This one's T, this one's R. And it's very simply, we can just count the units, or we can subtract the y coordinates. The y coordinates are 9 and 2, so we can say the y that's at 9 minus the y that's at 2 is 7, and we are going to call it units. Or we could have just said, okay, let's start here. 1, 2, 3, 4, 5, 6, 7. Okay, and it's that simple. So your job tonight, I just want you to do in the next 20, 30 minutes is to do all the rest of the non-star problems. Okay, if you need more of a challenge, do all of the problems, but on the top of your paper, please write that I'm asking you to do non-star only. Okay, and that's it. I hope you have a great day and that you enjoyed this lesson, and we'll see you tomorrow.